Action which is given right here, x and y are respectively, here are the options. Now let's look at what the reaction is. B2H6 plus 2KOH plus 2x gives the product as 2y plus 6H2. Now let's look at what are the values. Now here B is having the value 2, H is having the value 6 plus 2, which is 8. Oxygen has the value of 2 and K with its potassium has the value of 2. Now, or let's look at what the right hand side has. It has 2y and 6H2. Therefore, H value is 6 into 2, which is 12. Therefore, in order to balance the hydrogen atoms, we first need to substitute H here. Suppose we put H, we can ignore the answer B since it has only H atom, which will do nothing since we need 4H here. Therefore, we substitute the first value A. So if we substitute H2 here, we'll get 4H, which will be perfectly balanced hydrogen atom. However, H3BO3, if we substitute here, the number of hydrogen atoms will increase by 6 and hence they will not be balanced. The same case, now let's put H2O here. So if you put H2O here, hydrogen atom will be balanced and oxygen atom will become 4. Now let's look on the right hand side. If Y is KBO3, there will be 2K. Potassium will have 2 atoms. B will have also 2 atoms. However, oxygen will have 6 atoms. And however, on the left hand side, oxygen has 4 atoms. Therefore, this is also not the correct answer. However, if you substitute the value of D, we'll get a perfect equation on the left and the right hand side. Therefore, the correct answer here is option D. For the reactions C plus O2 gives CO2, the heat of combustion delta H is minus 393 joules, and for the second reaction the heat of combustion is minus 412 joules. Then either A, carbon can oxidize Zn, B, oxidation of carbon is not feasible, C, oxidation of Zn is not feasible, or D, Zn can oxidize carbon. Now let's look at the first reaction. The heat of combustion is, for the first reaction, H1 is minus 393 joules. And for the second reaction, the heat of combustion is minus 412 joules. Therefore, now, since the heat of combustion of Zn is less than C, therefore, Zn can oxidize carbon. C. Therefore, here the correct answer will be option D. The compound YbA2Cu3O7, which shows superconductivity, has copper in the oxidation state. We need to find out the oxidation state of copper. Here are the options. Now we have to assume that the rare earth metals yttrium is in its usual +3 oxidation state. Now therefore the compound given is YbA2Cu3O7. Hence we need to find the oxidation state of copper. Let that be as X. Therefore, yttrium has a +3 oxidation state, +2 into 2 plus 3x, which is this, and minus 2 into 7. Therefore, on taking the on calculating, we get 3 plus 4 plus 3x minus 14, which is equal to 0. Therefore, 3x will be equal to 7. Therefore, x will be equal to 7 upon 3. Therefore, here the correct answer will be option B. 1 mole of N2H4 loses 10 moles of electron to form a new compound Y. Assuming that all nitrogen appear in the new compound, what is the oxidation state of N2 in Y? There is no change in the oxidation state of hydrogen. Either it is A plus 3, B minus 3, C minus 1, or D plus 5. Now, N2, the product, N2 2 minus, loses 10 moles of electron to form a new product, which has a formula of Na plus 10 E negative. Therefore, we need to find the value of A, the oxidation state, which is A. Therefore, 2A minus 2 into minus 2, which is equal to 10, since 10 is the number of electrons that it loses. Therefore, on calculating, we get the answer of A as plus 3. Therefore, here the correct answer will be option A, plus 3. The oxidation state number of sulfur in H2S2O7 and iron in KuFeCN6 is respectively, here are the options. Now, let's find out first the oxidation number of sulfur in H2S2O7. Now, let the oxidation state of sulfur be actually X. Therefore, 2 into plus 1, which is the oxidation state of hydrogen, plus 2 into X minus 7 into 2, which is equal to 0. Therefore, plus 2 plus 2x minus 14 is equal to 0. Therefore, x is equal to 12 by 2, which is equal to plus 6 for sulfur. Therefore, sulfur has an oxidation state of plus 6. Now, let's find out the oxidation state of K4FeCN slash 6. Let's find the oxidation state of iron, that is Fe, which let that be as X. Therefore, 4 into plus 1 into X plus 6 into minus 1, which is equal to 0. Therefore, X will be equal to 6 minus 4, which is plus 2 for Fe. Therefore, here the correct answer will be option A, plus 6 and plus 2. A compound of Xc and F is found to have 53.3% Xc. Oxidation number of Xc in this compound is, here are the options. Now the atomic weight of Xc is 133. Now since the compound has 53.3% of Xc, therefore the other part of the compound is made of F, which has a percentage of 46.7%. Therefore, this makes up 100%. Now let's find the ratio of Xc is to F, which is equal to 53.3% of Xc upon the molecular weight of Xc, which is given as 133, is to 46.7 upon the molecular weight of F, which is 19, which will be equal to 0.398 is to 2.45, which is equal to 1.6. Therefore, this compound is known as xenon fluoride, XCF6. Hence, the oxidation number of Xc in this compound is plus 6. Therefore, the correct answer will be option D. Oxidation number of osmium OS in OSO4 is A plus 4, B plus 6, C plus 7, or D plus 8. Now let the oxidation number of OS be X. Therefore, in OSO4, this is X. For X plus 4 into minus 2 is equal to 0. For X minus 8 is equal to 0. Therefore, X is equal to plus 8. Therefore, the oxidation number of osmium here is plus 8, which is option D. The brown ring complex compound is formulated as FeH2O5NO plus SO4. The oxidation state of iron here is either A1, B2, C3, or D0. Now, the compound is FeH2O5NO plus SO4. Now, here we need to find the oxidation state of iron, which is Fe. So let that be X. Now, the oxidation state of H2O here is 0. NO is plus 1. This is whole plus 2. And SO is 2 minus. Oxidation state of oxygen is 2 minus. Therefore, we get value as X plus 1 plus 0 is equal to plus 2. Therefore, X will be equal to positive 1. Therefore, here the correct answer is option A plus 1. Number of P in Mg2 P2O7 is A plus 3, B plus 2, C plus 5, or D minus 3. Now, let the oxidation state of P phosphorus be X. In Mg2 P2O7, P is X. Now, Mg has an oxidation state of 4. This is 4 plus 2x minus 2 into 7 equal to 0. Therefore, 2x is equal to 14 minus 4, which is 10. Therefore, x is equal to 5. Therefore, here the correct answer will be plus 5, which is option C. The state of nitrogen is highest in A N3H, B NH2OH, C N2H4, or D NH3. Now let's look at the oxidation state of nitrogen in all the compounds of the solution. Now let the oxidation state of nitrogen be X. Therefore, in option A, we get 3 into X and 3H. So 3 into X plus 1 equal to 0. Therefore, X is equal to minus 3, 1 by 3. Now in option B, NH2OH, X plus 2 into 1 minus 2 plus 1 is equal to 0. Therefore, in the second state, oxidation state is X is equal to minus 1. Now in option C, which is N2H4, 2 into X plus 4 is equal to 0. Therefore, X will be minus 2. And in option D, we have, which is NH3, X plus 3 is equal to 0, which is therefore X is equal to minus 3 in option D. Therefore, hence the highest oxidation state of nitrogen is highest in option A, which is N3H minus 1 by 3. Therefore, correct answer is A. Oxidation number of P in KH2PO2 is A plus 1, B plus 3, C plus 5, or D minus 4. Now let the oxidation state of P in KH2PO2 be X. Therefore, 1, which is the oxidation state of potassium K, plus 2 into 1, which is the oxidation state of hydrogen, plus X, plus 2 into minus 2, which is the oxidation state of oxygen, which is equal to 0. Therefore, 3 plus x minus 4 is equal to 0. X is equal to plus 1. Therefore, the correct answer here is option A. The number of carbon in H2C2O4 is A plus 4, B plus 3, C plus 2, or D minus 2. Now, let the oxidation number of carbon be X in H2C2O4. Therefore, oxidation number of hydrogen is X. Therefore, 2 into 1 plus 2 into X minus oxidation state of oxygen is minus 2. Minus 2 into 4 equal to 0. Therefore, 2 plus 2x minus 8 equal to 0. Therefore, 2x is equal to 6 and x is equal to 3. Therefore, the correct answer here is option B plus 3. The number of N in NH4Cl is A plus 5, B plus 3, C minus 5, or D minus 3. Now let's look at the reaction. NH4Cl decomposes to form NH4 plus Cl minus. So let the oxidation number of N be X in NH4 plus. Therefore, X plus 4 will be equal to plus 1 since there's a positive sign here. Therefore, X will be equal to minus 3. The correct answer, the oxidation number of N, is therefore option D minus 3. Oxidation state of Fe in Fe3O4 is A 3 by 2, B 4 by 5, C 5 by 4, and D 8 by 3. Now let the oxidation state of iron in Fe3O4 be X. Therefore 3x plus 4 into minus 2, which is the oxidation state of oxygen, will be equal to 0. Therefore 3x minus 8 equal to 0. Therefore x is equal to 8 by 3. The correct answer here is option D, 8 by 3. Oxidation number of Mn in K2MnO4 and MnSO4 are respectively, here are the different options. Now let's assume that the oxidation number of Mn in both these compounds is X. Therefore, first K2MnO4, the oxidation state of K is 1, then 2K is 2 plus X minus 4 into minus 2, which is the oxidation state of oxygen, gives 8 equal to 0. Therefore, X will be equal to plus 6. Now, therefore, in MnSO4, X plus 6, which is the oxidation state of sulfur, minus 8 equal to 0. Therefore, X will be equal to plus 2. Therefore, here the correct answer is plus 6 plus 2, which is option B. Oxidation number of cobalt in CONH3 4 ClNO2. Either it is A plus 2, B plus 3, C plus 4, or D plus 5. Now let's look at this compound, which is CONH3 4 times ClNO2. Now let the oxidation number of CO be X. Therefore, X plus 4 into 0, since NH3 has an oxidation state of 0, minus 1, the oxidation number of chlorine is minus 1, plus 1 into minus 1 equal to 0. Therefore, X plus 0 minus 1 equal to 0, and X will be equal to plus 2. Therefore, here the correct answer is A plus 2. Oxidation number of nickel in K4 NiCN4 is A minus 2, B minus 1, C plus 2, or D 0. Now let the oxidation number of nickel in K4 NiCN4 be X. Therefore 4 into plus 1 plus X plus 4 into minus 1 equal to 0. For 4 plus X minus 4 equal to 0, and X is equal to 0. Therefore, the oxidation number of nickel in this compound is 0, which is option D. Number of ion in K3 FeCN6 is A plus 2, D plus 3, C plus 1 and D plus 4. Now let the oxidation state of ion be X in K3 FeCN6. Therefore 1 into 3 plus X plus minus 1 into 6 equal to 0. 3 plus X minus 6 equal to 0 and X is equal to positive 3. The correct answer here is option B. Number of N in NH3 is A minus 3, B plus 3, C 0 and D plus 5. Now let the oxidation number of N in NH3 be X. Therefore X plus 3 into the oxidation number of hydrogen, which is plus 1, equal to 0. Therefore X is equal to minus 3. The correct answer here is option A, minus 3. Equivalent mass of IO4 minus when it is converted into I2 in acidic medium? Is it A, m by 6, which is where m is the molecular mass, B, m by 7, C, m by 5, D, m by 4, or C, none of these? Now we know that equivalent mass is equal to molecular weight upon the change in oxidation number per mole. Suppose the molecular weight is m. Therefore, the oxidation number of I2 in IO4 minus is in acidic medium is 1 into minus 8 plus 1 electron is equal to positive 7, which is equal to positive 7. Therefore, the molecular weight will be m by 7. Therefore, the correct answer here is option B. One of the following reaction involves disproportionation. These are the following options. Now, first let us define what is disproportionation reaction. A reaction in which a substance undergoes simultaneous oxidation and reduction is called as a disproportionation reaction. In these reactions, the same substance simultaneously acts as oxidizing and reducing agent. Hence, if we look at option C, 2KOH plus Cl2 gives KCl plus KOCl plus H2O. Here, Cl undergoes simultaneous oxidation and reduction. Therefore, the correct answer here is option C, which is a disproportionation reaction. The following species will not exhibit disproportionation reaction: A, ClO minus, B, ClO2 minus, C, ClO3 minus, and D, ClO4 minus. Now, in disproportionation reaction or DR, one element of the compound will simultaneously get reduced and oxidize. Now if we look at CiO4, which is option D, oxidation number of Cl in CiO4 is equal to plus 7 and it cannot be increased further. So CiO4 minus will not get oxidized and will not undergo disproportionation reaction. Therefore, the correct answer here is option D, ClO4 minus. The following have been arranged in decreasing order of oxidation number of sulfur. There are different options. Now let's look at option D in general. So the compounds and their oxidation states. Now, first compound in option D is H2SO5, which has an oxidation here. So the oxidation state of sulfur is plus 8. Let's look at H2SO3. Here, the oxidation state of sulfur is plus 4. HCl2, here the oxidation state of sulfur is plus 2. And in H2S, the oxidation state of sulfur is minus 2. Hence, in option D, all the compounds are arranged in decreasing order, which is the correct answer. CuSO4 reacts with Ki, the oxidation number of Cu changes by A 0, B minus 1, C 1 and D 2. Now let's look at the reaction that is happening here. Now CuSO4 reacts with Ki to give K2SO4 plus CuI2. Therefore 2CuI2 gets Cu2I2 plus I2. Here the oxidation number of Cu changes from plus 2 to plus 1. Therefore, the change in the oxidation number is 1, which is the correct answer, which is option C. This has the oxidation state of +3 in A. Orthophosphoric acid, B. Phosphorus acid, C. Metaphosphoric acid, and D. Pyrophosphoric acid. Now let's look at option B, which is phosphoric acid, which has a formula of H3PO3. Now let the oxidation state of P be X. Therefore, 3, which is the oxidation state of hydrogen, which is 1 into 3, 3 plus X, plus 3 into minus 2, which is the oxidation state of oxygen, is equal to 0. Therefore, X is equal to 6 minus 3, which is equal to plus 3. Therefore, phosphorus has an oxidation state of +3 in phosphorus acid, which is option B. Oxidation state of I in IPO4 is A plus 1, B plus 3, C plus 5, and D plus 7. Now let the oxidation number of iodine I in IPO4 be equal to X. Now the oxidation number of PO4 is -3. Therefore, X plus -3 equal to 0. X is equal to plus 3. Therefore, the oxidation state of I in IPO4 is +3, which is option B. Number of P in PO4 3 minus, of S in SO4 2 minus, and that of Cr in Cr2O7 2 are respectively. Now let the oxidation number of P, S, and Cr be X. Therefore, in PO4 3 minus, X minus 4 into -2, which is 8, equal to -3. Therefore, X is equal to plus 5. Now in SO4 2 minus, X minus 8 is equal to -2. Therefore, X is equal to plus 6. And in Cr2O7 2 minus, 2x minus 7 into 2 is 14 is equal to -2. Therefore, 2x is equal to 14 minus 2, which is 12, and x is equal to plus 6. Therefore, the correct answer is option A, plus 5 plus 6 plus 6. Weight of potassium permanganate when it acts as oxidizing agent in ferrous ion estimation is, here are the different options. Now KMnO4 oxidizes ferrous sulfate to ferric sulfate as per the equation 2 KMnO4 plus 8 H2SO4 plus 10 FeSO4 gives K2SO4 plus 2 MnSO4 plus 5 Fe2 SO4 thrice plus 8H2O, or the same reaction can be written as 2MnO4 minus plus 16H atoms plus 10 Fe2 plus gives 2Mn2 plus 8H2O plus 10 Fe3 plus, and the equivalent mass of the oxidizing / reducing agent will be equal to the molecular mass of the atomic mass upon the number of electrons lost or gained by one molecule of the substance. Therefore, the molecular mass of KMnO4 is 158. Therefore, and the electron lost is MnO4, the oxidation state is +7, and in Mn2 plus, the oxidation state is +2. Therefore, the electron lost are 5. Therefore, equivalent weight will be equal to 158 by 5, which is 31.6, and the correct answer here is option B. Of potassium chlorate, oxalic acid, and sulfuric acid is heated. During the reaction, which element undergoes maximum change in the oxidation number? A. Sulfur, B. Hydrogen, C. Chlorine, or D. Carbon. Now let's look at how the reaction takes place. KClO3 plus H2C2O4 plus H2SO4 undergoes a reaction to form K2SO4 plus KCl plus H2O. Now here, in the first case, before the reaction, the oxidation number of Cl here is +5. However, when the reaction takes place and it is converted into KCl, the oxidation number of chlorine changes to -1. Therefore, chlorine undergoes the highest maximum change in oxidation number, which is option C, chlorine. Oxidation number of sulfur in H2S2O8, H2S2O4, and H2S2O6 are respectively. Here are the options. Now, let's look at H2S2O8. The structure of H2S2O8 is OH, S, double bond O, double bond O, 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 S double bond O, double bond O, OH, and it has oxidation number of +6. Now in H2H2O4 the structure is OH, S double bond O, S double bond O, OH, and has an oxidation number of +3. In H2H2O6 it has a structure of OH, S, S double bond O, double bond O, double bond O, double bond O, OH, and has an oxidation number of +5. Therefore, the correct answer is +6, +3, +5, which is option C.